My name is SteliosSoumas, and this is my EECS1021 bonus project, which is an indoor-outdoor temperature and carbon monoxide sensor. Here I have my computer with my source code connected over USB to my Grove Arduino with my MQ9 carbon monoxide sensor and my indoor infrared temperature sensor and my LED and my buzzer. Outside I have my Arduino Nano with my infrared temperature sensor for the outside connected via USB into my computer inside. Okay, so when I click run on my source code, it's going to prompt me, the user, to enter my desired temperature. I'm going to pick 22 if that's what my thermostat is reading. I'm going to click the button. It's now stored my temperature. And so it's now pulling up a graph, a live updating graph of temperature values. If I come over here, it's currently reading the correct temperature, okay, which is 22 degrees, has the outdoor temperature, which is 12 degrees, and then it has a carbon monoxide value. Carbon monoxide is okay right now, so there's no alarm going off. The indoor temperature is okay right now, so there's no LED going off. If I set my carbon monoxide threshold to something unreasonably low, like 1 part per million, and I pick a temperature that I know is below what this room's set at, which is 22, if I pick 0, you can already hear the carbon monoxide sensor going off, but once the program boots up and starts running, you'll see the LED turn on because it's telling you that the indoor temperature is too warm because I picked 0. And the carbon monoxide value is too high, it's over my threshold, so the alarm goes off. So if I set the temperature to something unreasonably high, like 50, and I come over to my setup, you can see that it's telling me it's too cold in here because 50 was my target. You can see it's reading the outdoor temperature as well from my outdoor temperature sensor connected out there. You can see that if I press my button, it clears everything, turns all the sensors off, and stops the connection with the board. For CLO1, I developed a unit test for both my voltage to temperature and voltage to parts per million carbon monoxide converter methods. Both function similarly, testing against a 2 positive input and a 2 negative input to see if the error value is returned, and then against both the max and the min bounds and 100 random values between the max and the min bounds to see if the correct value is outputted. When I run both tests, you can see that they both function correctly. For CLO2, I use the Java Swing API and library with its associated methods to solve the problem of creating a user-friendly and aesthetically pleasing way to get user inputs by creating an interactive user interface which allows a user to input a desired temperature and then use that value in determining the temperature state. I use the Princeton Standard Draw library and API and its associated methods to solve the problem specification of graphing sensor values to create a graph of the indoor temperature on the y-axis versus time on the x-axis. I use the Fermata4j library and API and its associated methods to solve the problem specification of communicating sensor values between my Arduinos and computer and use those values to write to an OLED screen and actuate an LED and buzzer. For CLO3, I use a hash map to create a collection of time and indoor temperature data before graphing. Data is added iteration by iteration using a timer task. After 10 iterations, the hash map is cleared to give the appearance of a live updating graph by starting with an empty hash map and adding values once again. For CLO4, I used an event listener to monitor for when the button is pressed and exit the system. I used an event listener to monitor for a change in the state of the carbon monoxide sensor and sound an alarm when the value reaches above baseline levels. I used the timer task to monitor the state of the indoor temperature and turn on an LED when it is too high or too low, relay what state it is to the user, and print carbon monoxide indoor and outdoor temperature data to an OLED and graph. For CLO5, I started by trying to implement JavaFX to create a GUI, but after testing I figured out that it worked in a complicated way with IntelliJ, and instead switched to using Swing and successfully implemented a clean, easy-to-use GUI. I used the concept of inheritance to use methods from JFrame and Action Listener from the Swing API in order to create a GUI that accepts user inputs. I used the concept of polymorphism to override both run and on-pin change methods to create a state machine based on carbon monoxide and indoor temperature values and create an updating graph. I used the concept of data hiding in order to encapsulate private variables within a certain class and keep them hidden from the user.